Hello everyone, this is Shashidhar on behalf of Edureka. So today we are going to see Talend Big Data tutorial, a very interesting topic, Talend with Big Data. Welcome one and all for this webinar. So today's Talend with Big Data agenda is like this. We'll first understand on a very big picture what is big data and how does Talend go along with big data, and TOS, that is Talend Open Studio for big data. How do we install it, whether it is similar to DI or any differences there, and we'll tell you how to install it, and also what are the big data components, the family of big data components in Talend, how does they help us, and we'll also show you one Talend demo job which will be working on big data. Now let's understand what is big data. Big data refers to the voluminous and complex data sets generated on the daily basis. So we all use Facebook, Instagram, you know how many millions of users are there, and all of us post some data. We have hashtags, all those stuff. And if you look at the medical domain, banking transactions, all of them are very huge data to handle. So these data sets can be structured, semi-structured, or unstructured in nature. So we need to have a tool which would help us in managing these kind of data. These data generally is useless and hold no meaning unless mined or analyzed properly. So if I give you a weblog of Flipkart or Amazon users, you should tell me what is his interest, what is he going to buy, all those stuff, right? So we have to analyze it in a proper way until and unless that data is useless. Storing and processing this data is really difficult. As we all know, RDBMS is not so good to handle big data, especially for the traditional data processing software. So this is the overall big picture of big data. So why do we call any data as big data, or how do we categorize it? So if you tell me an example, and if you ask me, tell me whether this kind of data is big data or not. So all of them will come to this point where we say 5 V's of big data. So what are these 5 V's? First one is volume, variety, velocity, value, and veracity. So volume is like it's increasing, okay, day by day. So today we have so much of users, tomorrow we have new users, and they are also going to post something on the social website. So our data is increasing. And what is variety? All of us will not post it in some way, or all customers will not give you no source data in one of the way. It will be a music file, it will be a JSON file, it can be a video, it can be an email, anything. And what is velocity? Bank transactions. So today, I being one customer of one bank, I can do n number of transactions. So similarly, other users, they also can access the system anytime they want. So the data generated velocity is very high. The frequency of new data coming in. So we all want real-time data, right? So that is what we are pointing to. So data is changing every second. And what is the value of the data? So that value of the data is depending on your business decisions. That is what you have to analyze from big data. So it all constitute to a very good value for analyzing that data. So what is that data important for? How much valuable is it? And then what is veracity? So you take data and you integrate the data from different geographical locations. So some of the columns will be null, which will be mandatory for you to take some reports. Few of them will be inconsistent or wrong data. So when it comes to clean up the data with huge amount of data which we are dealing with, it's a almost impossible thing. So that is also constitute to your veracity. So if your data is falling under all of these categories, we categorize them as big data, right? So hope you have got a good understanding on how a data can be categorized as big data. So our 5 V's will help you to understand. So any of this is available in your data, whether your data is very high, your data is variety, your data is changing very fast, all those stuff, then you can categorize them under big data, right? Now coming to big data technologies, that is Apache Hadoop. So what is Hadoop? So Hadoop is a framework that allows you to store and process large data sets in parallel and distribution fashion. So we all have heard about divide and rule strategy, right? So we have a piece of work, so we all can share that work and do it in parallel and get a solution quickly. So that is the big picture of Hadoop framework. So previously, why this idea was not implemented? At that point of time, hardware was very costly. So even though you had this idea in mind, that is divide and rule, there was not a framework present to do it because it demanded a hardware which was costly. And now in today's world, we get commodity hardware which is very cheap. So time is money now. we need the data and the report faster. So they are able to invest on hardware. So that is how Hadoop came into picture, and that is all. We are having more number of hardwares. We can parallelly process the data and get the results faster, right? That is a general understanding of it. So when we come to HDFS, what is HDFS? Hadoop Distributed File System. It is the file management system of the Hadoop platform, which is used to store data across multiple servers in a cluster. So group of commodity hardwares put together is a cluster, right? So now I have different systems. I can divide a work and give a piece of work to each of them and then collect back the result. So who is doing this dividing and collecting back work? Then comes the topic MapReduce. What is MapReduce? It is a data processing framework of Hadoop and mainly has two functions: mappers and reducers. So whichever I was telling you, we can assign piece of work to different servers, that is mappers, and once server has completed that work, we can get back the results, that is reducers, which run as tasks on various nodes in a cluster, and thus your parallel processing happens and you get the result in a quicker time, right? So this is Hadoop, HDFS, and MapReduce understanding. So before we go into the architecture, like, so what are, how, as I was telling you, there are different servers, and somebody called map will be dividing the work, and somebody called reduce will be taking back the results, all those stuff. So you would have a little bit of confusion how it is happening internally, right? So that is why we are giving you a glimpse of the HDFS architecture. As you can see here, I was telling you about different servers, right? So how they are represented here is like they can be data nodes. Okay, so each data node will have blocks which can hold the data, right? And at any point of time, we'll have a replication of data. Why we are introducing commodity hardware? They may be, prone to fail. So we should have a replication of the data so that our data is available at any point of time. Okay, and this is fault tolerant method. At any point of time, one replication will be available. That is how this framework is designed, right? So we'll have data nodes in one of the racks, like how I said, we'll have different servers. We can have series of servers in one rack and another series of servers in another rack, right? So all these things are called data nodes. So who will divide the work and how will take back the work? So we should have somebody who is managing all the stuff, right? So who manages all this is the name node. So name node is master here, which will speak to all your data nodes, and it will manage the task, and it is kind of an interface between HDFS and your program. Okay, so that is what you have to understand, what is name node and what is data node. And there is a fault tolerant method which will make my data availability at any point of time. Okay, so name node is the master, data nodes are the one which actually executes the task, and each data node will have blocks which will store the data, right? And why we are telling about name node and data nodes is, so in our ETL job which we'll be doing today, we will have to configure these values. So you should know, whenever you're configuring those values, you should know what actually you're configuring. So that is why we have introduced the name node and data node concepts here. So now let's try to understand what is resource manager. So there'll be something called yarn, which is our resource manager, which will be managing all the node managers. Okay, what is this node managers? As we saw in our previous architecture slide, we had one name node and 5 data nodes. Okay, so this is one example of it. So we can have different name nodes and different data nodes in the cluster, right? So in that case, we'll be having more than one name node. So node managers are the one which will manage all the name nodes. Okay, and when we have different name nodes, so we need different node managers. So that is what is represented over here. So when we have different node managers, obviously we need someone who will manage all these node managers, which is called a resource manager. Okay, so resource manager is like, it takes all the requests and it will maintain, first job will go to this name node, second job will go to this name node. So that is how it manages. So resource manager is the one which will manage all your node managers, and node managers in turn manage your name nodes and data nodes, right? Now let's understand what are the big data technologies available. So first we'll speak about Apache Hive. So Apache Hive is a data warehouse system built upon the Hadoop system. Okay, we have Hadoop distribution file system. Upon that, we have an interface where we can speak to so that it goes back and fetches the data from HDFS, right? So it is used for analyzing structured and semi-structured data. So what is the a selling point of Hive is way behind when big data came into picture. There is a need for somebody who writes these mappers and reducer jobs. Okay, that was in Java. But at that point of time, there were so many people who had database experience, but not the big data experience. They only knew how to write SQL queries. Okay, but when industries wanted to migrate to big data, they wanted an interface wherein if you write an SQL query as you write for RDBMS, it would convert that into map and reduce programs, and it would fetch back the details for you as you require, right? So that is where Hive came into picture. Hive lets you perform queries similar to SQL through high query language, that is HQL. So Apache Hive supports DDL, DML, and user defined function, just like our stored procedures. So what Hive made was it enabled people who knew databases, who knew SQL queries to just continue their job as they were doing with RDBMS, but the same query would work on big data. So how easy is this? So that is why Hive become famous. So this is all about a big picture of Hive. Coming to the next big data technologies, that is Apache Pig. So what is Apache Pig? So Apache Pig is an abstraction layer in HDFS and was introduced by Yahoo. So Yahoo had a white paper on Pig and they developed this. So how is Pig different from Hive or what it does? So it is a platform for analyzing large data set stored in Hadoop distribution processing clusters. So Hive and Pig are used to one or the other way to interact with your HDFS. But how better they are and in which cases we have to use Hive and which case you have to use Pig, you can now understand. So Hive, if I have a resource who knows SQL, he can directly jump in and write SQL queries to analyze the big data set, right? And what is the specialty of Pig? It helps in performing mass scale parallel computation on big data with lesser lines of code. So one line in Pig may be equal to some n lines in HiveQL or in your Java. So it is very easy and very powerful. So two main components are Pig Latin Pig language and Pig compiler. So using Pig, whatever aggregation reports I want, sales report, monthly report, yearly report, so I can do aggregations with big data very faster. So that's how it is optimized way of using them for reporting things. Okay, so that is why Apache Pig is famous for. So now let's understand how Talend has coupled these big data technologies. What are the components available and why it has become so famous with big data. So Talend with big data is first of all is automated. So you would all be surprised like what is this automated? So as I mentioned earlier, so big data needs mapper and reducer jobs to do any of the big data processing, right? So we don't know how to write that map or reduce programs. Neither people who were using Hive knew it. They would only write the SQL query which would automatically be converted. In the same way, the components which we are using in Talend, we have to just configure them for required details to go and connect or to do some specific actions. But here also, we are not writing any mapper and reducer programs by ourselves. So it is automatically generated. So that is how it is automated. It is very easy as you've already seen the previous video of Talend DI. So it is just drag and drop, configure and plug and play. So it is affordable, it is available in your open source, enterprise version, even enterprise version is affordable and fast. Ultimately, the backend code is Java and the compilation and execution speed are just like Java, so it is faster. So with all these selling points, Talend with big data is a very big hit. So Talend Open Studio for big data. So what are the features of it? So Talend Open Studio for big data is built upon the Talend's integration studio. Okay, so it is a superset. So if you download TOS for big data, it is like TOS for data integration plus big data components. Okay, so why we have this difference? So if you are not at all working on big data components, why would you simply download the related components which are there in big data version, right? So only if you are working with big data, you can go for this product. Otherwise, you can do everything which is available in big data in DI as well. So DI is a subset and TOS big data is a superset which is containing DI. Okay, so it is again an open source software and provides an easy to use graphical development environment to the users. So the learning curve is very less, so you can learn it very quickly, and it is psychologically designed for whatever option you just go and search in the palette, you'll get a component, you just have to configure them, use it. So TOS for big data at the backend will automatically generate the underlying code in Java. So the native code is in Java, so it generates your Java files. It is a powerful tool which leverages the Apache Hadoop Big Data platform and helps users to access, transform, move, and synchronize it. So it is tightly coupled with Apache Hadoop Big Data platform. So after you see the components, you'll understand it is very easy. Like just how you develop a normal DI job, you'll be developing the big data job as well, and you'll be surprised to see that. So coming to the advantages of Talend Open Studio for big data. So as I already mentioned, fast designing. You just drag and drop, configure them, and tell specific programs to work on, aggregations, report generation, whatever it is. So better collaboration. We have all the big data components for customized components, and we have special components for pig, which will work on pig related file types, all this stuff. So early cleansing. As I mentioned, one of the feature of Veracity, wherein before going to big data, we can do all the cleansing operations in DI and then put them into big data. So efficient management, as you know, it's all optimized code which is getting generated. Your mappers and reducers will also be an optimized code, which will be an efficient management. And easy scalability, as you already know, you can scale it up, scale out, whatever you want with big data along with Talend. So together with all these advantages, we'll see how Talend Big Data works. So we have to first download the TOS for big data. So we'll have to just log on to talend.com under download section. So we have the download section. In the download section, we have the big data. So data integration plus big data components will be your big data thing. So if you download only big data, it is as good as downloading data integration plus big data components, right? So once you click on this link, you will be starting your download, which is again a zip file. So if your download doesn't start, you'll have a link to restart your download over here. You can just click on it. So once your download is complete, so you'll have your zip file downloaded here. So once you unzip it, you'll have executables for all the environments. Like if you're using Windows, if you're using Linux, so you'll have the executables related to them. So you can launch the right executable as per your system requirement. So once you have launched the executable, you'll be seeing a window like this, which opens up Talend Open Studio for big data. I'll be showing you all this step in demo as well. So we'll have to create a project to start our development. So we'll have to click on create project and then give a valid name for the project and just tell finish. So once you do that, you'll have the welcome page open. So you can close the welcome page and we can start a new job. So this is how your TOS big data opening page looks like. So big data components in Talend is what we are going to see now. So once we see and get to know about what are the components for big data, then we'll start the demo. So big data family in Talend. So if you can see in the palette, I'll be showing you in this demo as well. So in the palette under big data, we have all the possible big data which are tightly coupled with Talend already present here, like Cassandra, and as we already spoke about Pig, Hive, they are also present, and we have HDFS components which deals with file management and all other things present over here, right? So big data family for Talend. So these leverages the power of big data technologies. So Talend provides a wide range of built-in components for big data. They're all already available. You just have to drag and drop and use them. Using these components, you can connect to the modules of the Hadoop system, right? HDFS. They create connections to various third-party tools used for transferring, storing, or analyzing the big data. So it's just like how you use the Talend data integration. Take the components to read, write, or filter out, do aggregations, whatever you want. So for all of them, big data components are already available. So big data family for HDFS. So we have THDFS connection. We have THDFS put, that we have the file in local system. We'll have to first transfer that to HDFS. So after you transfer that, using THDFS input component, we can read the data from HDFS. And once we have done the analysis or the business rule applications, and then we'll have to put in a different format back to HDFS, we'll have to use the THDFS output component. So THDFS connection, which helps us in connecting. So here is what I need, all the configurations, what I mentioned, right? The name node, what is the URL for the name node, what is the URL for the resource manager, all those stuff will be provided in HDFS connection. Using those inputs, we'll be able to connect to the right HDFS system. Okay. So this component helps in connecting to the given HDFS so that other Hadoop components can reuse the connections like HDFS put or input. So this creates a HDFS connection. And as I already told, HDFS put, it just helps copying files from user defined directory and it would transfer them to HDFS, is also capable of renaming them. So once I transfer them in HDFS, I can even rename them. And THDFS input as a component helps in extracting the data in HDFS file so that other component can process it. I can read the input and I can give it to a filter or an aggregator and I can do whatever my requirement is. And ultimately, THDFS output is for transferring the data flows into given HDFS file system. So we have connection, input and output components, and for file transfers also we have standard components. So this is all our HDFS majorly used components, and we have other list of components like here, like we can compare the HDFS files, we can copy, delete, we can check whether a file is existing or not before processing it. We can have raw output. We can check the properties of an HDFS file. Okay, we can rename or get the count. So all these things are already available. These are the widely used components. So this is the complete family for HDFS. So let's see for Hive and Pig. So big data family for Hive. So Hive has a very limited components and we can achieve all our requirements using these components only. We have T-Hive connection as the name suggests. So it helps in establishing the connection. So resource manager is required in T-Hive connection, which we already saw in the architecture, and T-Hive input. So this component helps in executing the select queries. So Hive is all about your SQL, right? So if I am taking this input component, I'll be able to write the SQL queries as I know only them. So that input component code will convert my query into mappers and reducer programs, right? So it sends the data to the component that follows. So T-Hive load is a component which helps in writing the data to different formats. So I'll have a file which I have to load it to HDFS. So via Hive, I'll be able to load it as a table, right? So different formats into a given Hive table or in exporting data from a Hive table to a particular directory. So it also does multiple function. It loads and also inserts the data into a table, right? And yes, before we could insert data into the table, we should have a component which will help me in creating a table, right? So we have T-Hive create table, which helps in connecting to the Hive database being used and creates a Hive table which will be dedicated for the data in specific manner, right? So though we have a file like HDFS, everything is file, right? HDFS is file system. So though they are underlying stored as files, via Hive, I'll be retrieving that data in file as a table. So which I know, and how to analyze the data, I'll be aware in SQL language. So that is how these components help me in converting those SQL queries and work on big data. So let's see what are the big data family for Pig. So again, big data family for Pig has few more components because Pig way of storing the data is different. So we need to have different components for analyzing the data, right? So that's why we have more components here. We have tpig aggregate, we have tpig distinct, we have filters, dedicated components for Pig itself. So tpig load, this components help in loading the original input data to an output stream with a single transaction. So after the data is validated, so I have complete data set, every validation is completed. So if I give it to a pig load, it does it in one transaction. So it will always be one row. I'll be showing that. So pig load is to load the data to your HDFS. So what is pig map? So this component helps in transforming the data from single or multiple sources. Again, these tpig map can work on your pig components only. So they are all dedicated components. So you can take multiple sources, you can join, you can do some transformations, and you can give out the different filter result as well. So TP aggregate is a component, as the name itself suggests, it's used for aggregating the data based on one or more columns. And we also have tpig join, so which helps in executing the inner joins and outer joins of two files, only two files. Tpig map can work on more than two. Tpig join can work on only two. right? So it joins, and in order to create the data used by the pig sources. So what is the difference between pig join and pig map is pig map can do many things like joining, filtering, writing into different flows. So it's a heavy component. It has a lot of code since it is doing multiple functions. But pig join is very dedicated to only joining, and we cannot do any different transformations over there. So it's a light component. So if your intention is only to join, we should actually go for pig join, which is more optimized. If we have a requirement for transforming, filtering, and then joining, we can go for pig map. So that is how the difference is. So this is a complete big data family for pig. So we'll first see now how to develop a big data job in Talend. We'll take a very simple use case. Say for example, we are using country names, maybe which countries being in social media a lot. Like today I have 5 countries which are going trending on hashtag. And then in the first row I'll be getting 6 country names separated by space. Okay, I'll be showing you that file. Likewise, I'll get a data for a month or a year. So I'll have to now, it's a big data when it comes to an year, every day, what is the trending hashtag or something like that. Then I have to analyze which is the most trending one, or I need to give an orderly way, like which is first, which is last. So I'll have to analyze on a very big data set. So given this use case, so how do we do a job in Talend Big Data is what we are going to see now. As we have showed you in the slide, how to download the TOS Big Data. So once you have downloaded the Talend Big Data, so it will be the zip file as already mentioned. So once you unzip this, you'll be having a folder like this for Talend Big Data, and which would include all the binaries for your Windows and Linux. So since I'm using the Linux VM, I'll be opening the Linux exe. That's shell script. And this is the only step you'll have to follow to launch the Talend Open Studio for Big Data. The prerequisite will be Java should be installed and Java Home should be configured. That's it, no other steps. We will get a welcome page like how we are seeing, where we'll have to create a project to proceed. So now we'll create a project by clicking on create a new project option and then provide a valid name. Let's call it Edureka and tell create. So it creates a new project in Talend Open Studio for Big Data. Once it is created, we'll have to select that project and see finish, and that opens up a Talend Open Studio for Big Data for your development. So I'll just click on finish. It opens up a welcome page for me. Once we finish the project, we get a welcome page from Talend Open Studio for Big Data. We'll just close it, and then the other windows get activated, which you're seeing. As we have explained all other windows in our previous video. So in repository where I create the jobs, and these are the configuration windows, and this is the palette window where I'll have all the component listed. Once I create the job, all these windows will become active. So how do I create a job? I come to repository, I click on job designs, I right click, and I say create job. Provide a meaningful name like J stands for job, big data demo, and I say finish. So once we have created the new job, it opens up a designer window for us for the development, and this is how my designer window looks like. So I'll have to first create the HDFS connection to start my use case. So I'll come to palette and type in THDFS, and I get all the related components. I'll drag and drop THDFS connection component into my designer, and I'll start configuring it. So for the first configuration, the property type will be built in because we are providing the values manually. Otherwise, we'll have to go for repository, which is metadata. And for the distribution, since we have our own setup, not like we are not going into any of the sandbox, hence we choose custom unsupported. Whenever we say distribution is custom unsupported, we have to provide the configuration jars for Talend. So I'll be providing them by clicking on this button. So I'll choose import from zip option. I have the the set of jars which is required for HDFS connection, which is provided by the setup team. So we'll need all this information to connect to HDFS. So by just giving the zip file with all the jars, all our property settings will be taken care by Talend. So it has imported all the jars required for HDFS connection. So I simply say OK, and I start with other options. So authentication will be username, and here comes the name node URI option. So that is why we had included in our architecture diagram and gave you an insight of what is name node. So the name node URI will be HDFS, and since I have my own HDFS setup in localhost, my server name will be localhost, and the port for name node will be 9000. So we don't have to give any other mandatory options. So username will be Edureka. With this, my configuration for THDFS connection is complete. So once THDFS connection configuration is done, my next step for the use case is I'll have to move my input file, which is out.csv, which is there in my local host. I'll have to move this file to HDFS system. So let's see how we can do that. So as we have already seen in the PPT, which is the component which will help me to load my file which is in local to HDFS is THDFS put component. So I'll search for THDFS put and I find this component over here. And the other method is I can directly type in over here THDFS put, which puts files onto HDFS. I'll take this component. So on successful connection, how will I control my flow of components is right click on this connection, say on component OK. That means successful connection is done. Then you can move a file from my local to HDFS. So once HDFS connection is successful, we are moving to THDFS put. So there in THDFS put, I'm using use existing connection and I'm saying I'm connecting to the previously created connection, that is HDFS connection 1, and the local directory is documents, wherein I have a file name out.csv. So from this local directory, the file name is out.csv, and when I move it to HDFS, I'm renaming that as uscity.csv, and this file will be moved to user folder in HDFS, right? So by doing these configurations, I'm moving the file from my local host to HDFS. So my second step of my use case is done. So after I have moved that file, I'll have to read the file from HDFS and I'll have to implement the solution to do the word count on the city names, right? So which is the component used to read the data from big data is THDFS input component. So I would take the input component, and as you already know, I'll directly click this option, use existing connection, and then I say HDFS connection. But before to that, I'll have to provide the schema name. So I'll have only one column which will have city name, which will be a string, right? So after this, the file name which I'm going to read is, after it has moved, it will be from user, and when that file is moved, it would be renamed as uscity.csv. So I'll take this value and I'll tell to read that file which will be created. And it is a text file, and it has space as separator. It doesn't have any field separator because we'll be, space will be the field separator which we'll be using to denormalize later to do the word count. But initially we don't have any, we have only one field. And with this options, we are able to complete the THDFS input configuration. Once both these components are finished their work successfully, on subjob OK, I'm creating this. So the flow will be first THDFS connection, on component OK takes the precedence and moves the file. Once it has successfully moved, on subjob OK will be triggered, and then it will read the input, right? And now after reading the input, we'll have to now normalize the data. So I'll take normalize component and I'll take this input and give it to normalize component. And normalize component will have the same schema, and also if it is not having, I can tell sync columns, and I'll tell to normalize it based on space, because if you observe my input, I have space in it, right? And then by this way, I am able to convert each of my single row as a space as delimiter, I can create each of them as single values, right? So after this, since each city name will come out of this t-normalize component, I can give it to an aggregator component. So I'll take this value, provide it to t-aggregator. And in this t-aggregator, I'll be configuring them as, so I'll take this city name, but the output I want is the count of it, right? So I'll create count and make it integer. And I'll have to group by the city name. So city name will be my group by. And what operation I have to do is I'll have to put value into the count column, and the function I use is also count, and I count the city names and I ignore the values, null values if any, but space is still a handler for us. So we'll get one row in aggregation which is for space, since we are normalizing for space delimiter. You'll see in the output. So once this aggregation is completed, the data coming out of this aggregation row, I can just give it to THDFS output. And this can be, again, I'm using use existing connection. Columns can be synced, and I'm using the HDFS connection. And the file name which I want to create is, so in the user itself can just tell create a new file by saying US city counts, something like this, and then it is a text file. It can be, action is create, and row separator is /n, and field separator may be pipe, and that's it. So in this way, I'll be able to read the input from big data, do my normalization, do an aggregation on that so that I get the count of each of the city, and then the result I'll be storing it to THDFS output, right? By this, actually, we have completed the use case wherein by running this job, we can see the intended output. So, but I'll also try to introduce to one more big data technology, which we already saw in the PPT, that is Hive. So let me take this file, which is created as an output in this THDFS output component, and let me load that data into Hive so that we can query that data using SQL query. So what I'll do, after this successful creation of this file, again on subjob OK, I'll create a Hive connection using Hive connection component. So on subjob OK of this, that means all these components will finish their execution successfully, and then come and create a Hive connection. So again, if any jars are needed, we can install them directly. Once the required jars are completed, download is complete, then we'll start configuration of the Hive connection component. So again, Hive also is a custom setup in our VM. So I'll choose the custom unsupported, and I'll provide the required jars for the configuration. In the similar way, we have it for Hive as well. So Hive connection. So I'll just say OK, and it will import all the Hive connection related jars. So all the jars has been imported for Hive connection. So once all the jars are imported, then I'll tell use yarn, which is my resource manager related options. The connection mode will be standalone since it is on my local host, and Hive server will be Hive server 2 by default. My host is localhost, port is 10,000. A database which we have already created for demo purpose is Edureka. If you are doing it for first time, we can use default database, which is a default database which is existing in Hive. And for this, I don't need to provide any username and password since it is already there in my local. I'll have to just provide resource manager, which is again in my local host, and port is 8032. And we'll have to provide the name node URI, which is HDFS localhost 9000, which I already used for the HDFS connection as well. And I have to provide my Hadoop user, which is Edureka. So providing all this information, my Hive connection should be successful. And then, which I've already created this file over here, I'll have to load it to a table. So before I'll have to load that data from file to a table, I'll have to create a table. So we have a component to create table. So Hive create table is what I'll take. Once connection is successful, on component OK, I'll tell to create a table. So for that, again, I'll tell use existing connection, and I take the Hive connection and schema. Anyways, my report is having city, which is a string, and count, which is an integer. So with this structure, we'll create a table for US city count table in format of text file. So we have create table option. So the best option we can choose is create table if does not exist. So it will only create if it is not existing, and then the field separator will be semicolon. So with this operations or settings, we will create the table in Hive. So once this table is created, using thive load, we can load the data from the file which we have created in HDFS to this table which we are creating now. So after this table is successfully created, I'll just go to thive load. So thive load also I'll tell use existing connection, and I choose the Hive connection. So action will be load, and the file path which I'll have to load is which I have created in thdfs output. So for Hive, we'll have to give the path from HDFS only. So that is why HDFS path is provided here. And the table name which we are going to load is the table which we are creating in thive create table, which is US city count. I'm copying that value, and I'm telling load this file data to the table which is here, right? So it will use action is append. So let's leave it with these options. And then since my file is of pipe delimited, let me also give pipe delimited over here. So with all these settings, let's now run the job and check if there are any problems. So now we have completed the development of the complete job. We'll have to now execute and see whether it works as per our requirement. But before we go on to the complete execution, let's first finish the execution till the final output which we are expecting in HDFS is created or not. That is because when we do an Hive load, it actually clears out the data in HDFS after loading it to the Hive. So let's break the connection over here, and let me deactivate this part of Hive and only run till this part and check whether my requirement is right. I mean, it's creating the file with the required data. Okay. So the now job is executed till the final output is reaching the HDFS output. So now let's first see the first step, whether it has moved the file from Edureka documents folder, that is out.csv, to user folder in HDFS by the name of uscity.csv. So how do I browse it? I go to localhost 50070 and I say browse this HDFS folder, and we can see, I'll refresh this. So we have us.city.csv created over here, and let me show you the content of it. So it is the same file which we have moved from local, which was out.csv, and now it is available in HDFS with the name uscity, right? So with this, we have moved the file from local to HDFS. So after we have moved that, we are using thdfs input to read that file, and we are splitting the city names, and we are aggregating them, and we are creating a output file with the name US city counts in the same folder. So now let's check whether we have that US city counts file. Yes, it has been created. Now let's see the content of this file. So now we can see we have the aggregated report with city name and count, how many times it has been used. And as I mentioned already, since we are using the space as delimiter, we'll get the values for space as well, which we have to ignore and consider this rows for our business decision purpose, right? But our intention is to load this data into Hive. So let's go on and activate the section which we have deactivated for a reason that it clears out the file which is being loaded into Hive. So now we'll activate that section and we'll run this job and see whether there'll be a table created, and then do we have the same data which was there in HDFS in the table, and we can query that using the same SQL query, right? So now it should create a table with table name US city count, and it should load the data from my HDFS file which I have created to this table. So now let's run this job and check whether we have the required output. Job has been successfully completed now. So now, as the last check for our output, we'll have to log into Hive and check whether this table has been created and this table has the required data, right? So we'll check that. Let me log into Hive now. I'll open the terminal and I see Hive. Now I'll use the command show databases. So it has default and Edureka. So I'll tell to use Edureka database since I have used that database to create my table. So once we are using this database, let me check whether my table is created or not by using show tables command. So US city count has been created. Now let me check whether it has the data which we had created in HDFS output, and we have loaded that into Hive. So I say just a simple SQL query, select star from US city underscore count. So I have the output which was already there in my HDFS, and same thing is being it has been loaded into my Hive. And then by using SQL query, like imagine me as the guy who only knows the SQL query, I was just able to write an SQL query to read the data which was there in Hive, but actually the data in Hive is underlying in big data HDFS, right? So with this, we complete the simple use case which we have taken. And what business decision can be taken is the Los Angeles is the highest used city name in the social media is what the decision which I can take, and based on that decision the investments or the future plans can be taken. So this is all about the demo which we were planning to give you on big data demo. Hope you have enjoyed it. Thank you one and all for attending this demo. Please follow us for further updates and videos on Talend. Thank you.